Hey everybody, Mr. Mack here. We're going to look through the notes on 2.5 quadratic equations, and we're going to break this up into two sections. First one, just going to solve equations by factoring. So we've done a lot of factoring already, and the next thing we need to layer on this is the zero product property, which says that if A times B equals 0, then A can be 0 or B can be 0. So let's take a look at solving a quadratic with leading coefficient of 1. And so we know that we need to find the factors of -6, that add to 1. Okay, so we know that when we multiply our binomial together and we do FOIL, the O and the I ends up being the sum of the factors that give us the L. So we could have a factor of -1 and 6, whose sum is 5, or factors of 1 and -6, whose sum is -5, factors of -2 and 3, whose sum is 1, and factors of 2 and -3, which is -1. So we are looking for the sum of 1. So that's going to be factors of -2 and 3. So let's break up our binomial here to x minus 2 times x plus 3. Remember, we are reverse foiling with this factoring of this trinomial. Now we want to use the zero product property again. A times B equals 0. So A could be 0 and B could be 0. So in this section, we know that x minus 2 has to be equal to 0. And x plus 3 has to be equal to 0. Because those quantities, if they are 0, then it satisfies our equation. So we'll solve for x, and we get 2, and we get -3. So let's check that. I'll check a couple of these. It's always good to check. We're going to substitute 2, and we're going to substitute in -3 for x, and we're going to make sure that it satisfies the equation. 2 squared is 4, plus 2 minus 6. 4 and 2 is 6. 6 minus 6 is 0. This works. All right, let's check our other solution of -3. -3 squared is 9, minus 3, minus 6 equals 0. 9 minus 3 is 6. 6 minus 6 is 0. That works. So we'll take a look at graphing in the next unit, I think, but just so you see that when we factor a quadratic, the x-intercepts end up being the solutions, because that is when our y value is 0. So you see where the parabola hits the x-axis, our y values are both 0 there, -3, 0, and 2, 0. So the x-intercepts are the solution to the quadratic. I don't know if you can hear it, but it is pouring outside. Next example, solve the quadratic equation by factoring again. This is just like the one we did before, except we are looking for the factors of 15, whose sum is 8. So we're going to make another little chart. So factors of 1 and 15, or 15 and 1. And the other one is 3 and 5, or 5 and 3. And that's it. So 3 and 5 are my pair. And I'm going to set up my two binomials. Now I'm thinking, what makes the parentheses, the quantity 0, so I'm going to set up x plus 3 equals 0 and x plus 5 equals 0, and then solve for x. I get -3 and negative 5. And that's our solution. And we could check this, but I think I'm going to move on here. Let's take a look at the difference of squares. So we spent some time looking at this in radicals. We've seen or conjugate pairs with radicals. We've seen it with imaginaries. We have the difference of two perfect squares. That means that a conjugate pair is going to be our factor. So what are the square root of x squared is x, and the square root of 9 is 3. So we do x plus 3 times x minus 3, set the quantities equal to 0, and solve for x. So we got x equals negative 3 or 3. Why don't we check this one? So let's substitute negative 3 in for x. Negative 3 squared is 9. 9 minus 9 is 0. Okay, that worked. And let's try putting a positive 3 in for x. Again, we get 9 minus 9 is 0. So those are our two solutions. Okay, example 4. Okay, this one's different because the leading coefficient is not 1. We have 4x squared plus 15x plus 9. Notice, by the way, that we're writing these quadratics in standard form. Ax squared plus bx plus c equals 0. And the way we solve these, the way we factor these, is by multiplying the a times c term and then finding the factors of that equal our b term. So our a and our c are 4 and 9. So we're going to do 4 times 9. And our b term is 15. So 4 times 9 is 36. Now we need to find the factors of 36 that add to 15. So 36 has a lot of factors. 1 and 36, that doesn't work. That is 37. 2 and 18, that gives us 20. That didn't work. 3 and 12 is 15. Ah, that's it. So just to show you here the other factors, 4 and 9, that doesn't work. And 6 and 6 doesn't work. So 3 and 12 are the factors. Now, we are going to now take the original trinomial and split up. I'm just going to rewrite it here and leave some space here in the middle. We need to rewrite the 15x as the 3 and the 12x. So I'm going to write 12x first because I know that the 4 and the 12 have a common factor. And then the 3x and the 9. And I know the 3 and the 9 have a common factor. It doesn't matter the order, but if you can see which one factors in the groups a little bit more easily, then I just go ahead and set it up that way. So let's take a 4x out of the first two terms. That leaves us with x plus 3. Let's take a 3 out of the second two terms. That's our greatest common factor. And notice we have x plus 3. We have to have the same quantity for this to work. That'll let you know that maybe you made a mistake. So the x plus 3 is the common factor for these two terms. So let's factor out the x plus 3, and that leaves me with 4x plus 3 in the other quantity. Now it's time to use the zero property of multiplication. So I'm going to take x plus 3 and set it equal to 0, and then I'm going to solve for x there, and then I'm going to take 4x plus 3, set it equal to 0, and solve for x. So I get x equals negative 3, and then my second I get x equals negative 3/4. So I got the graph of this quadratic just to show you right here, and you can see the x-intercepts are the solutions. So we have -3 and -3/4. It's hard to see the -3/4, but that's approximately where it is. And those are our solutions for that one. Last one. So we have a higher degree here. We have an x cubed. So one of the things we try to recognize in all of our terms in the polynomial, is there a common factor? And I hope you see that x is in each one of those terms. So let's take out, and they're all negative, so let's take out a negative x. It's easier to deal with positive terms, and that leaves us with 3x squared plus 5x plus 2. Now this trinomial right here has a leading coefficient of 3. So we need to do the same, follow the same steps as we did in example 4. We need to find the factors of the a times c that add to the b term. So a times c is 6, so 3 times 2 is 6, and 5 is our b term. So this is fairly straightforward, right? 1 and 6, and then 2 and 3 are the only factors that we can use. And the 2 and 3 add to 5, so that's what we're going to use. All right, so we just have to make sure we stay organized here with how we write this next step. This negative x still needs to hang out in front. That was originally factored. Now we've got 3x squared, and let's write, okay, so just 5x plus 2, that's equals 0. Now let's break up that 5x. Now I'm going to say plus 3x and plus 2. If you notice, you can just see how the factors work better in that order. You could do it the other way and it's fine. We get the same thing, but I'm grouping the 3's and the 2 terms together. So let's factor that out. 3x is our GCF for the first 2. Leaves us with x plus 1. 2 is our GCF for the second 2, or the last 2. Leaves us again x plus 1. And then don't forget to bring down that negative x. Okay, so let's factor out the x plus 1. This is now fully factored. We can use the 0 property of multiplication now, but we have 3 here. So negative x could be 0. The x plus 1 part could be 0, and the 3x plus 2 part could be 0. It's going to solve each one of these. We get 0. We get negative 1. And we get negative 2/3. Okay, let me just rewrite it over here on the right. X can be 0, negative 1, and 2/3. And that's it, everybody. Those are our notes for this first part of quadratics. Hope that makes sense, and I'll check you later.